This is the key for the first exam. Starts out with how many significant figures are in each of the following. Alright, so here we have a couple of zeros in between numbers, but those are always going to be significant. So here we have 1, 2, 3, 4, 5 numbers that are all significant. All non-zero numbers are always significant. Alright, here, zeros left of the 1 or of a non-zero number, and the leading zeros, those are always insignificant. They're never significant figures. The zeros after a non-zero number, the trailing zeros, are significant if they're after the decimal place. Okay, so these ones will be significant, and we'll have 1, 2, 3, 4 significant figures. All right, here we have zeros. They're trailing zeros, but this time they are before the decimal place. Okay, 36,000 kilowatts, and so this will be just 2 significant figures, because if they are before the decimal place, they're there just to tell you where the decimal goes. They're not actually part of the measurement, so that's just 2 significant figures. Okay, here we have a zero, trailing zeros after the decimal place, so that is going to make those significant, and that will be 4 significant figures. Alright, bear in mind, as long as there are zeros after the decimal place, even though this zero is not after the decimal place, it is still, that zero makes all of it significant. Alright, and here, a trailing zero after the decimal place, so we have 3 significant figures. Okay, a couple of extra comments. The times 10 to the 4th has no effect on significant figures. That simply moves the decimal place. It doesn't change the number of significant figures. And also, units just tell us that this is a measurement where significant figures are important. But you know, milliohms, you've probably not seen that symbol before. It doesn't matter. Whatever units you have is really irrelevant to significant figures. Alright, round the following to 3 significant figures. Okay, so 1, 2, 3, this will be 34.9, but then because this is an 8, we're above 5, we're going to round that up. It'll end up being 35.0. Okay, bear in mind that we're going to have 3 significant figures in the end, and so that's what this zero, trailing zero after the decimal place, that is a significant zero. Alright, here these leading zeros are never significant. Okay, so 1, 2, 3, 4, 5 significant figures. We're going to round it. Right here, and I'll go ahead and write my line there. And the 7 is greater than 5, so this will be 0.000461. Okay, so we leave all of those there, but we're just rounding it to this place. All right. Here we have a number less than 5, so we're going to round it off. Okay, so we need 3 significant figures, so that'd be 420. But here we run into a little problem, because if we just wrote 420 like this, this zero is not significant. Alright, trailing zero before the decimal place. So in order to get 3 significant figures, we have to write this number in scientific notation. So the way we're going to do that is put the decimal place here. Now we have 4.20 and then we say, well, we need to show you that this decimal is really over here, so we're going to move it 2 places to the right. Okay, just like that, and then we would put in the units for all of these here, megagrams and meters. Okay, so now the 0 is after the decimal place, and therefore it is, as it's written here, it is a significant 0. All right, so that's how we write a significant, or write a number like this where that 0 would be significant. Okay, moving on. For each of the following, identify whether it is a physical property, PP, physical change, PC, chemical property, CP, or chemical change. Okay, so here we're talking about the flammability of acetone. Okay, so flammability. First of all, is that a change? No, it's not talking about burning, it's talking about the flammability. So that would be a property. Now what do you have to do to determine the flammability? You have to put it through a chemical reaction. So that is going to be a chemical property. Okay, density of mercury. Okay, again, this is going to be a property, not a change. There's no process happening here. And density is something that we just measure the mass, we measure the volume. We don't have to put it through any chemical change. So that's going to be a physical property. Color of carbon. Okay, likewise, color is a property, and we don't have to put it through any reaction. We just look at it and we see its color. All right, so that also is a physical property. And the reactivity of sodium, all right, very similar to the flammability. We have to put it through a reaction in order to determine its reactivity. Right? So that would be a chemical property. No change happening here. It is a property. Okay. The corroding of copper. All right. So now we're talking about a change. It's corroding. It's something is happening. So the corroding of copper. This, when copper corrodes, it is no longer copper. It is some other compound. And so this will be a chemical change. Right? Food digesting, likewise, this is a process. Something is happening. It's a change. And certainly the digestion of food is a chemical change as well. What comes out is not the same as what goes in. All right. Now, benzoic acid melting, again, another change. This time, though, it's melting. It's going from a solid to a liquid. But either way, it's still going to be the same compound. So that one's going to be a physical change. All right? And likewise, evaporating gasoline, a change is happening. It's evaporating. But it's still gasoline. It's just in the vapor state. All right? So that is a physical change. Okay? Now, indicate whether the descriptions are of a pure substance or a mixture. Okay? The components may only be separated by chemical means. Right? We have to put it through some kind of a chemical process in order to separate the components. That must be a pure substance, because a mixture, we don't have to put it through a chemical reaction. We can separate it by some other means. Okay? And here is an example. Filtering is used to separate the components. Right? So if you have some kind of, say, particles in your water, you have some dissolved minerals or something, and filtering, you put a filter on your water supply, that's a physical separation. Okay? And so that would just be a plain mixture. It's not a compound that is formed. You can't filter out a compound. you can only filter out something that is not chemically joined. Okay, so that would be a mixture.